Bye. Hello, everyone. My name is Zach, and this is Science Explosion at Hudson Public Library in Hudson, Iowa. All right, so I want to thank you so much for joining me today. So, today we're going to be talking about calories. So, I know this is probably really interesting to some people and kind of boring to others, but bear with me because I think it's a lot more interesting than you might think it is. So, what even is a calorie? It's something that you hear all the time. Everybody talks about them, but I'd say very few people actually know what a calorie is. And I'd say there's a little bit of reason for that. So I'm going to start off with what the actual definition is and then tell you what that means. All right, so a calorie is something that is, so it's a unit of measurement and it's all about energy. So it's the amount of energy that's needed to raise the temperature of 1 gram of water by 1 degree Celsius. All right, so that kind of makes sense, but it gets a little bit more complicated because the things that you call calories are not calories. So we actually just use an abbreviation and we use kilocalories. So kilo or kilo means 1,000. So it's 1,000 times what that is. So when we say calories on things like nutrition labels, what we're actually talking about is a kilocalorie. So that is 1,000 times more. So that's going to be the amount of energy that it takes to raise the temperature of a kilogram of water by 1 degree Celsius. And that's at 1 atmosphere, by the way, if anybody wants to get really technical about it. All right, so you can build what's called a kilometer, and that will measure how many calories something has in it. But I'm not going to do that with you today. If you're interested in doing that, then I would definitely recommend you doing it. There's lots of plans on how to do this online. The supplies aren't too hard. If you have a couple cans of different sizes, then you are about halfway to doing that anyway. So, all right. I want to show you what this actually means, though, that food has energy. So you might have heard this before, but why do we eat food? So that's a great question. So part of it has to do definitely with the taste. And I've talked in the past videos a couple times about why food tastes a certain way. If you want to watch the one where I make a cake, I talk about why we like tastes like sugars and fats and things like that. But other than the taste really has to do with directing what kind of foods we eat. But why do we eat in general? Well, think of yourself as a robot. I know you're not quite a robot, but we can be pretty close here. So robots need an energy source to run, whether that's solar or whether that is gas or whether that's a battery, whatever it is, you need an energy source to run. And we're no different. So eating is where we get our energy from. So when I take something like this marshmallow, if I eat it, this will then go into my body and I will get the energy that is inside this marshmallow. All right, so I want to show you how there is energy inside of marshmallow. So I've got these little mini marshmallows here. And have you ever made marshmallows over a fire? All right, so I'm working with a lighter, and if you're ever using a lighter, remember safety first. I've got water on hand in case I need to put it out, and I'm right next to a sink. All right, so I'm gonna light this on fire. I don't know how long it'll take. There we go. That fizzled out. I figure I might need a little more than that. There we go. So there you go. Now that it's caught fire, you can see the fire right there. This marshmallow is burning. Now, you can see it pretty clearly right there. There is a flame. Why is this marshmallow burning? All right, so I actually did a whole video on what fire is all about. But basically, to sum it up, fire consumes energy. I'm going to blow that out so it doesn't smell too much like smoke in here. And then you can see it's all crispy. But the fire is basically consuming energy of this. So if this thing didn't have any energy in it, I wouldn't be able to burn it. Now, I know that some of you might be thinking, well, I can burn lots of things, but it doesn't mean we can eat them. And that's true, but it doesn't necessarily mean that nothing can eat them. So I could burn a piece of wood, but even though we don't eat a piece of wood, there are things that can. Think of things like termites or carpenter ants are able to process those. And now, if I eat this marshmallow, because I've burned some of it, oh man, that is burnt. Oh my. So this marshmallow that I just ate has fewer calories than the first marshmallow because I've burned some of them off. So the definition of a calorie is a little bit complex, and it's not something that you can test out unless you have a kilometer, which I will say, again, they're not too hard to build. But it seems to me that that's not really a useful definition for when you're really trying to deal with this in everyday life. So what's really going to help you is think of calorie means energy. So the more calories a food has, the more energy it has. All right, so I've got marshmallows right here, and they are full of calories and energy. So there is not too much in this compared to other junk foods. There's 100 calories in 2/3 of a cup, according to the back right here. So that, little bit of char right there. So that amount of energy, if I were to eat 2/3 of a cup of this, which that's a lot of marshmallows, then I would be getting 100 calories from that. So what does that mean? So I already said it's the energy of that. So I want you to think about that a little bit. So the energy from these marshmallows is going inside of me. All right, so energy seems like it's a really good thing, right? So you need energy to be able to run. But what happens to that energy? Well, your body doesn't store it just as calories. It tends to store it as a couple other things. So the go-tos are sugar and fat. So your body can store a lot of things short term as different types of sugars like glucose. But in the long term, what your body does if you get more calories is it's going to store them in its favorite way and an incredibly efficient way as fat. So fat, if you're wondering, inside your body and any other animals, it is a concentration of calories. And just in case you're wondering how many calories it takes to get a full pound of fat, I've got it right here, and I just want to check to make sure I'm telling you right. It is 3,500 calories. So if you were to have 3,500 calories just extra in a day, which is quite a bit, that is the equivalent of getting 1 extra pound of fat. And by the way, that is, I think, 10 calories a day. If you were to have an extra 10 calories a day, that is an extra pound of fat. So I know that some people in here are probably already scared just by the mere mention of the word fat, but keep in mind your body does need some of it. The problem comes if you have too much of it, not if you don't have any. So everyone, even bodybuilders and incredibly thin people, have some fat in their system. It gets fairly dangerous if you have something like 2% of your body or lower. But for most people, that's not as much of an issue. There are definitely some people who struggle with not getting enough. They're what's called underweight, but most people are overweight. Now, why is that an issue? If having energy is a good thing, why would having too much energy be a bad thing? Well, that's a really great question. So think about it like your car. So This won't work if you have an electric car because this is going to be a little bit different, but you could think of it in terms of batteries instead of gallons of gas. So think about your car. So your car needs to be filled up with gas to be able to run, right? Again, if you have an electric car, think of batteries instead of gallons of gas, but I'm assuming most people watching this have a gas car. So your car needs gas to run. Now, what would happen if you have extra gas in the car? Well, to a certain point, that's pretty good. And from nature's point of view, it's a good thing to have a little bit of extra fat on you. But if you have too much, it starts weighing you down. So if I were to have an entire car's worth of weight of extra gas, my car's not going to run very well because it's going to be too heavy. Well, that's actually similar to what happens with people. So if I were to gain, some people would be double the amount of fat as to all the other cells in their body, those people are going to be weighed down so much by it that it's actually going to cause everything else in their body to have a hard time running. So that's everything from walking to your heart working and things like that. So that's just the absolute bulk of it. There's also some problems of where it goes when you have too much, like if it gets inside of your heart. That's not a good thing if you have too much fatty things like cholesterol inside your heart. But okay, this is not a health lecture. But I think that's good to know what this actually means, because I'd say most people actually don't know what fat is or what calories are. But basically, calories are your body's, it's the energy that we use to measure this. So calories aren't really a real thing. They're a shorthand. So that's a quick way of saying something. So not everybody uses calories. In England, I believe they actually use joules on their food, which is another measure of energy. But what's important to know is that calories represent the amount of energy in this. And something like this has a lot of calories, a fairly large amount of calories in it. Now, the reason why people warn you against things like junk food isn't just because of the calories. It's because they have lots of calories, but not much of anything else in them that's good for you. So this has, by the way, this also has 16 grams of added sugars, which is just 2/3 of a cup of this. If you were to have that, that is your daily recommended value, 32%. So if you had 3 servings of marshmallows, that is more sugar than you should be getting in an entire day just with those things. So the reason this is junk food is because it has calories, but it doesn't have things like vitamins that you need in it. It does have some things like carbohydrates, and you do need some carbohydrates, or carbs is what people usually shorten them to. But the big difference is this has calories and it has sugar, but if you were to eat something like an apple's also got nutrients, plus it has something called fiber in it. And fiber is something that helps you to digest things better instead of it all getting absorbed in your bloodstream all at once. That's what's going to happen with these. When I ate those, it's pretty much just rocketing into my bloodstream. All right, so you hear people talking about calories a lot, and even though I'm saying they're not really a solid thing you can grasp, they are really useful in figuring out how much energy is in something. So these have 100 in them. If you were to have, all right, so I've got a chart here that actually helps you to think of how much it is. So if something is calorie dense, that means it has a lot of calories in a small serving. So 200 calories, so that's about 2 servings of this. How much broccoli do you think you could eat and get 200 calories? Well, 588 grams. And how much is that? That's an entire plate full. You could eat an entire plate full of plain broccoli and only get 200 calories. Whereas it'd be 51 grams. So that is, I'd say, about a dozen gummy bears. Or you could have, let's see, 1/2 of a glass of soda. Or you could have about 2 or 3 plates worth of celery. There's not many calories in celery at all. Or you could have an whole apple. Now, peanut butter was the one that surprised me. That's 34 grams. So that's basically like a teaspoon of peanut butter. or you could have half a honeydew, or if you wanted mini peppers, you could have a whole plate for, or if you wanted a cheeseburger, and this is going to be like a cheapo McDonald's garbage cheeseburger. Sorry, McDonald's, I hate fast food, but that would be half of a cheeseburger. So that's 75 grams. So this helps you to think just a little bit about that. So what, so I think it really helps to think of the calories as being like energy. You need some energy to run, but think about the gasoline thing again. If you're giving a good version of that, it's going to help you run better because these have extra junk in them that if I were to eat this, it's going to give me the calories I need, but those sugars and some of the other just kind of junk in here is actually going to end up slowing you down because it's got other things added to it. All right, but I think it's fun to talk about this nutrient density. What would this actually power if it was powering something other than you? So 5 pounds of spaghetti could brew a pot of coffee. A piece of cherry cheesecake could power a light bulb for an hour and a half. And if you had 217 Big Macs from McDonald's, you could drive a car 88 miles. I don't know why they wrote that, but that is incredibly specific, but I think it's interesting. So food is energy. Food is basically the power source that makes things work. All right, so why am I talking about calories in terms of energy and how much is in different foods? Well, Americans actually eat way more than they used to. And I'm not exaggerating when I say way more. So, all right. So, in 1985, people were actually already eating much more than they used to in America. And we still have 300 more calories each day, and that's each day, than we did in 1985. And remember what I said, 10 extra calories a day over a year is 1 extra pound that you would gain. And we eat 300 more calories a day than we used to in 1985. And that's even more than it used to be. So between 1971 and 2000, calorie intake actually rose 7% for men and 22% for women. I think it's interesting that there's that much of a difference in it. I think there's lots of different reasons why, and you might want to think about why would there be those differences? It's an interesting question. All right, so that has to do some with what we're eating at home, but it also has to do with what happens when you go out. So when you go out to eat and you order something, do you think what you're getting is a serving size? So a serving size is how much something is recommended that you have in one serving. So when you go out to eat to a restaurant, do you think what they're giving you is a serving size of what you're eating? So I can tell you the answer is almost certainly no. So when you go out to eat and you get something, you will likely get 2 to 8 times what an actual serving size is. So that means there are a lot of places you'll go that, let's say you get something like French fries. So that'd be a serving of potatoes. So that is going to be usually about 3 or 5 times, 3 to 5 servings, just in a thing of fries of that. I think people don't quite understand that we eat a lot larger amounts of food than we really should be doing. All right, so this one I think is interesting. The average cookie sold in a restaurant is 7 times larger than an actual serving of a cookie. So that's actually partially because things like this, things like sugar, you're only supposed to be getting a very small amount of day, where most of the foods that we actually get in a standard American diet are very high in sugar. I'd say the average American, I don't have it written down here, but I believe that it's at least 4 or 5 times the amount of sugar you're supposed to be getting in a day is what the average American does. Some people will be getting up to 1,000 times more sugar than they should be getting in a day, and that is quite unhealthy. And you see that the effects of that happening all the time. All right, so calories were discovered in 1824. I think that's just kind of neat, but I want to show you what calories actually do. So I talked about how you can burn things, and I talked about them being a unit of energy, but I want to actually show you that that is true. So what I've got here is 2 potatoes, and I'm going to do a classic potato clock. So there are 2 zinc ends and 2 copper ends. So you're going to take your potatoes, and I've got one of them hooked up to a clock here. Stick a zinc in part of it there, and then a copper in the other potato. And then wherever you stuck the copper, stick the other zinc. So you can see this one is connected just like this. And then I've got one that's just these ends connected to a different wire. So I'm going to stick the zinc in the one with the copper. And I'm going to stick the copper in the one with the other zinc. All right, so I didn't set this clock, but you can see it's running. So you can actually see that this potato has the energy to power this clock. There are no batteries inside this clock. It is just a straight up potato clock running this. All right, so I think that's pretty neat. So if you want to try this at home, you easily can. You can either buy a kit for this, or you can just get it. You'll need at least 3 wires, and then you'll need 2 zinc and 2 copper ends to stick into this. And I would encourage you to look it up yourself as to how it works. But basically, I think that is a good way to show that there is energy inside of food. So, all right. So if you have any other experiments you'd like to try to demonstrate the energy inside of food, I think that is something that is really neat. So, all right. So the average calorie intake per capita. So this one's a little bit old, but I think it's still somewhat relevant. It's gone up a little bit since then. The United States, so the average person's recommended to have about 2,000 to 2,500 calories a day. So the average person in the United States gets about 3,800. So actually reaching almost to double what they should be getting for some people. So I think that's really interesting. So, all right. And if you want to know how many calories you actually should be getting, then there is an easy way to find out. So for women, you need about 10 to 11 calories per pound that you weigh to maintain how much you weigh. And for men, you need about 12 to 14 calories per pound per day. Now, this is for adults. This is not for the kids watching this, because if you are a kid, you are growing and you're actually going to need a lot more calories than the adults around you, because those calories are being put straight back into you to build things as you grow. So all of your bones, your muscles, joints, whatever, it's building you as you grow. So you're going to need a lot more than that. But for the adults, for if you're not going up and down in weight, this is what you're going to be getting. All right, so you might have noticed, by the way, on a personal note, I've dropped about 55 pounds over the last year, and that is because I have partly a reason for that is because I am actually what's called a calorie deficit lately. So a calorie deficit, so the word deficit means that there is less coming in than there is going out. So I am using more calories or energy than is being put in. So for now, that's okay, because it should balance out eventually. I'm in a fairly stable way, but you don't want to do that for too long, because if you're on too much of a deficit, then that means that you're just going to keep going down, and eventually you can't keep that up. Now, most Americans are actually at what's called the calorie surplus. So a surplus means that you have more coming in than is going out. So, all right, so that's just a little bit about calories today. If you have other ways that you want to try that, then you can. So, I want to leave you with a couple other things that you can try. So, on a related thing, there's a fun experiment I think you can try. And did you know that a lot of the food in your from scraps that you get from different plants, you can actually turn those back into the same plant that it was before. So, if you have something like these potatoes here, now let's see. You notice that little thing right there on the potato? That's called an eye. And that will actually sprout a root. So if you were to cut that thing off into about an inch by an inch cube and let it dry, you could then plant that in the ground and that would turn into some new potatoes for you. Otherwise, you can do things like if you have a head of lettuce, if you cut it off at the base, and then put that in some water, it'll actually sprout new leaves. Same thing with celery, it'll do that pretty similarly. So try some of those if you can. So ginger is a great one. It'll just form from any part of the roots. Let's see, carrots are another good one. If you have the carrot top, you can just plant that right down into that. I actually think what's best is plant it in water to start, get it to sprout a little, and then you can put it in the ground. All right, so I'm also going to leave you with a little bit of an interesting one I just found, and this is Harvard Medical School's healthy eating plate. So this is a recommendation on what kinds of things you should be eating in your day. So on the side, you should be having water, and then you need to have about half your plate as fruits and veggies, more veggies than fruits, but lots of fruits are good. And then you also need to have proteins and you need to have grains. They actually recommend healthy oils, which is a little bit different than what some other organizations do. But I think this is actually a pretty good one. So I am actually quite critical of the USDA's MyPlate. I think it's actually quite wrong on a number of things, including the fact that even though the vast majority of the world is lactose intolerant, they recommend that people have dairy. So it is interesting. I will leave you with that. So thank you everyone so much for joining me. This has been just a little bit of a talk on calories. So have a nice one. Bye.